Yeah, it sounds, she just wants to make sure that it's ideally executed.
It's like me with my ties. Let's bring up awkward high school dance corsage moments.
It's prom season too, so this is it's a good time to be talking about that. Did you grow up around here, Jen?
No, I've been very much a nomad in my adult life.
Really?
So I grew up in Western Massachusetts, literally as far away from Boston as you can be and still have a Massachusetts driver's license.
Yeah.
And then Philadelphia, Baltimore, and now Chicago. And then I'm in Detroit probably every other week with work.
So if you were far away from the Boston side, like Pittsfield?
Yeah.
So this is where you got like plastic in your blood, right?
My grandmother and my aunt worked for GE Plastics, I think, when Jack Welch was there in like their 70s or whenever he started cut his teeth there, yeah?
Yeah.
Yep, so I grew up further, like a half hour west of Pittsfield.
So do you still have family there?
Yeah, my mom's family is still in that area. And then my dad's family's from Philly, so when I got out of school, he actually sold our house and moved to Philly. And then I got a job north in the Lehigh Valley. That was with Mazak.
That's where you were based?
Yep. And that was great. Just grew up a Phillies fan, but never got to go to too many games as a kid, so caught up the few years that I lived there in a hurry. Went to a ton of Phillies and Flyers
I
games.
just edited that show.
So
Okay. Did it come out well?
Yeah.
So, yeah. It was
when
Looked wonderful.
Bobby Gray Hall was big in Indy and Mazak
That
was a
Joanne,
sponsor
right? From the show, yeah, that's what I
of
thought. There we
Ray
go. Chris
Hall's
is here a lot too.
team.
We
I went to the Indianapolis, my wife and I went to the Indianapolis 500 with Brian Papke and his wife.
I know Brian very well. He kind of retired.
Yeah. And his son,
Yeah, Chris and Greg.
Greg.
Yeah. We actually can't say who, but there's a very well-known former like Sprint Cup champion that's going to be starting an additive service provider soon.
Really?
Oh, that's interesting.
Sorry, I'm just getting Joe's shot and I'll come back.
Yeah. So that's actually.
Are you guys working with him?
Hopefully, I mean, he's basically prospecting which company he wants to go with. So hopefully us. I remember Mazak was working with Penske when I was there.
Right.
How recently?
What?
How recently retired?
He actually might still. I don't. In full disclosure, I don't follow NASCAR that closely. I know the name. He might still be driving and might be planning post. I mean, it's a guy that I think has won within the past 5 years. I mean, he's definitely won a race. I don't know. I think he's won the overall championship.
I don't really follow NASCAR.
Not-
Yeah.
and-
Well,
disclosure.
here's the problem. Nobody does, which is why NASCAR is up for
Right.
sale. We talked about that one of the shows I was on recently.
But if I.
Okay. I want to thank everybody who is joining us today. This will be a very fascinating show. We're going to get the inside on 3D printing additive manufacturing. So get your questions in for our guest and for our journalist panel as well, which will have an extensive journalist panel at the end of the show. So send them an email, viewer mail, all one word, at autoline.tv or via the YouTube chat, or reach us out to us on social media accounts, and I'm sure that you know what they are. It's not here. You can also call us at 620-288-6546. That's 1-620-AUTOLIN. Are there still letters on phones?
A lot of them know.
Yeah. 620-288-6546. Leave us a brief question, 30 seconds or less, and we'll try to get it on the air. So stay tuned. We'll get going in just a minute.
Yeah, that's a problem. I don't.
Watch Autoline After Hours live at Autoline.tv every Thursday at 3 p.m. Eastern Time. That's 12 p.m. Pacific. You can subscribe to this podcast for free by searching for Autoline in iTunes, Stitcher, or YouTube.
Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion, and by Lear, a global leader in automotive seating and electrical systems.
Okay, thanks for joining us. John is on assignment, so I'll be doing the hosting duties today, and therefore I needed to have serious help. So I have Chris Paukert from Roadshow.
I don't know how serious I am, but happy to help however I
The
can.
new Vice President of North American Car of the Year Award jury, so
Very kind of you.
congratulations
Thank
to
you.
that. And Joe White from Reuters.
That's me.
probably has forgotten more about the auto industry than the rest of us know.
I've certainly forgotten a lot. There's no doubt. I know a few things.
You know.
Let's see how much.
And our special guest, who brought a multitude of examples here, so we'll get some real insight, John Walker, who is with EOS North America. So EOS, for those of you who are not familiar with it, is a company that makes additive manufacturing machines, 3D printing, rapid prototyping, that whole thing. It's been in business since 1989, founded in Munich?
Yes, that's correct.
Munich, Germany. But you're based here. And so I think the place we should start is, tell us what this is. I mean, everybody talks about it, but I think people don't really understand it.
Sure. So 3D printing is a technology that's been around since the late 1980s, and currently EOS is involved in two different forms. We're involved with plastic SLS printing and metal DMLS printing.
Right. That means?
So those are two types in a large world of what we'd call additive manufacturing. And traditionally, like if you were to compare us to machine tools, and if you wanted to make a round part, there might be 5 different types of machinery to make a round part. 3D printing is no different in that there's at least 5 or more different ways to make a part. And the general process is, if I wanted to manufacture this part, I would design it on a computer in CAD, and then I would put it through a build processor that would take this part and slice it into like 20,000 layers. And we basically spread a layer of powder, and then we take a laser and fuse that powder together to make our finished shape. And then we do that 20,000 times, stacking the layers on top of each other, and then we get our finished part like this.
So those layers must be awfully thin.
Yeah, we actually mostly work in the metric system, but traditionally we are anywhere in the metals machines from say 20 to 60 microns, and on the plastic side of the business we're around 100 or 120 microns depending on the material or the process.
And for those who are listening, the podcast of this show, so this part is not only formed in terms of an arc, but it also has texture on it. So that comes with the build, or you add that on later?
Yeah, no, this is actually all built into the parts. The only thing, and again, apologize for people listening to the audio, they can't see, but the part in my hand is blue. And really the only limitation, and that's the limitation of our style of 3D printing. There's other style of 3D printings that would more lend themselves towards aesthetic prototypes. Versus all of our 3D printing is supposed to be direct part replacement. So our SLS technology will be the closest you can get to injection molding out of a 3D printer. So we can basically do white or black, and then if you want to add color to your part, you dye it afterwards. But the leather texture and the circular geographic patterns, the honeycomb, those are all designed in CAD and then printed directly into the part.
Mm-hmm.
So you're right, this technology has been around and been talked about for a number of years. Where are you in terms of getting to parts that are both from a quality perspective good enough to use out on the street, in case of cars, and the process is fast enough or reliable enough to support any kind of mass production, or is it still sort of specialty application at this point?
So 2 out of the 3 items you just identified we can knock out of the park right now, and that is process stability and that is quality. So we've been in business for about 30 years, and for the first, I'm going to use round numbers, not a little less than 10, say 22 years we were in business, the focus was on creating a process that was stable, and somebody could load a CAD file, load the machine with aluminum powder, let the machine run, and then 10 hours later get a functional aluminum part that was 99% or 100% dense and had properties that matched forged or wrought materials. And the big emphasis was on quality because the concern was if the quality wasn't good, a large organization like any of the big 3 here in Detroit would buy a machine, want to get into metal printing, and then the machine would fail because the process wasn't good, and people would misunderstand and think 3D printing wasn't ready for prime time. And the reality is the machine is, the process wasn't. So for those 20 plus years it was process. And now that we have the process and the machines at a very high reliable standpoint, now we're figuring out how to make them faster. We're figuring out how to automate them, and we're picking off the low-hanging fruit one by one so that we can get into higher volume applications. So in our world right now, we've done a lot of time studies and things, and on the plastic parts, anything less than 10,000 parts, and again, it depends on the size, and the more complex the part is, the better it is for 3D printing. that's kind of an interesting volume for us to look at. But some of the automotive volumes right now where we might make 1 million of something like a knob on a radio, that's just not a practical part for us yet.
So this part you're holding in your hand right now, this is a real part, and this is a part that would be very difficult to make with any other process. Is that correct?
Yeah, absolutely. So generally we say if you have, and a great example is automotive. We've been building cars in the United States for about 100 years. There's a lot of processes in place to cast an engine block, to make a hubcap, to make a wheel, to make a piston, all these different parts, a crankshaft. There's a 100-year process in place, and especially with the cost pressures in automotive, all the big three and their suppliers have this stuff down to a science. So for you to bring us an engine block and say, hey, 3D print this, we're going to put it in the next Silverado, it doesn't really make sense. But if you come to us with a challenge and something where you're not getting, you're leaving some food on the table with performance improvement, or the part is so complex like this one where we know this is the right way to make the part, but I have no idea how I would machine this, or I have no idea how I would make the tool to make this part, that's something interesting. And the other thing with 3D printing is you can't solely focus on the individual cost per part. You need to think about the whole process. So this part right here is actually what General Motors just did, and this was built on an EOS machine. This was the existing part.
So what is that part?
Yeah.
This is a seat mounting bracket, and this is 8 individual stamped components that are either welded or bolted together. And this is the design optimized part for 3D printing. So the story here is that this is a part that they would like to try and get into production with an electric vehicle. There's a huge benefit to weight savings on the electric vehicle. The lighter we can make the cars, the better the battery life. And we start looking at complex components on there and figuring out how to make them lighter. So the story in this part is that this is 8 individual parts. This is 1. So we need to understand the entire cost to make 8. So there's the cost for the tooling, there's the cost for the actual stamping process, there's the cost for the assembly. This comes out of the machine, minimal post-processing, and it's ready to go. So we've eliminated the tooling cost. So even though this finished part costs X and this one might cost Y, and Y is probably more expensive than X, if we've cut the tooling costs out of there, we've cut the assembly costs out of there, we've cut the tooling design costs out of there, we've cut the electrodes that might be involved on the EDM side, like there's all these other processes that we cut out of the equation, and now we have something to talk about, and the total time and cost of this might be X, and now our Y should be less expensive and faster.
So are you able to produce that, that part, the very complex and kind of artistic part that you've got in your hand there, is that something that takes how long to build up from first spray?
Yeah, so generally speaking, and I don't have, being that, this is General Motors IP, I don't have the exact cycle time, but just shooting from the hip, just based on the height, that might be like a full 24-hour build time. But in that 24 hours, I would want to nest as many of these parts as I could fit on the machine's build pallet. And hypothetically, I might be able to fit 6 of these on the build plate. So in 24 hours, I would get 6 of these.
So you're still talking about small volume applications right now. But we've been talking about 3D printing for a very long time already, but it's really intensified over the last 5 years, the conversations around it. It's gone from prototyping to production applications in small volumes in certain cases. What's the hockey stick curve on the development for that? Is there so much attention around it now? There's so much development and so much money pouring into this that you're looking at a rate of improvement of what X versus what you were 5 years ago on a yearly basis?
Yeah, so I can say in the last 2 years, if we just look at the costs alone, I think it's pretty safe to say from 2 years ago to today, just the costs alone have probably come down about 20%. So there's a savings. And then when we look at new technologies, we're doing things. So I mentioned we got the process stable, and now we're figuring out ways to take this incredible process and make it faster. So we've added multiple lasers to our system. So our largest machine is 400 millimeters for the build envelope on the metal side, and we now have 4 lasers in that machine. So it's not a perfect factor of 4 faster, but say it is 3.7 times faster because there's a few non-productive times that are in both systems. So now we've come down 20% in cost, and we're almost 4 times faster. We showed a new plastics machine in Europe last year, which will be releasing in 2019. And that machine is twice as fast as any of the existing plastics technology, and that's fully automatable. And this part here is actually a part from Daimler and an Airbus company, and they are building the world's first automated 3D printing factory in Germany.
For Airbus.
Yes, this is an aerospace part, but it is Daimler, and obviously I think we can all make the short putt that hopefully they're able to proof of concept in aerospace and then get that going into Daimler products for transportation.
So we're looking at parts here. We have a question from one of our viewers, Dave Tuttle, and he's basically saying rather than printing parts, why not print the tools that then can be made through which you can make the parts?
He's absolutely correct. So today, it's actually in production. Unfortunately, with NDAs, I can't say who, but there is a mold shop in Michigan that is doing a part for one of the big three that goes in an interior component. And there was one interior component made out of plastic that was extremely difficult to produce, and they integrated conformal cooling. So they took this existing tool and made an insert that was 3D printed and had water lines that run near-net shape to the surface of the mold. And then you can also make them in spirals and different shapes so that you get more water running through the part. And you're not limited to straight. So if my molding surface is up here and I can only drill straight, it might be 2 or 3 inches from the molding surface. With 3D printing, I can build things in the middle of the part you don't even see. And I run those water lines through the middle and up towards the top of the surface. So that gives us better temperature control in the molding process, which allows us to mold faster, so less cycle time per shot, and then gives us better temperature control in the plastic. So they had an issue on this particular plastic interior component. They used conformal cooling, and they were getting the plastic, the quality, the temperature control is better, and now that's in production in a vehicle.
And I mean, isn't it just the case that if we are going to be, say, running a limited production volume to test out parts, that you can quickly make a mold and make a few thousand parts with the 3D printed mold versus sending it out and having it machined?
But you could. I mean, the metal that comes off it is dense. There's a company in the Toronto area called Exco, is a huge die caster. They've got, thousands and thousands of shots. They have die cast tools in production. So the tooling we make is production grade tooling. You could absolutely do one and do it that way, but it is production grade.
So I'm sorry. So your process is able to create a mold or a tool that can be used in high volume production.
Absolutely.
And so in order to do that, what's the cost difference between your process for making a piece like that or a product like that and the traditional process of machining, polishing, all the rest of it? So additive is one part of your process chain to make your finished tool in this case. So we're not going to get if grinding or polishing is required to get that mirrored surface finish that's going to give you shiny plastic, that's not a process you can get rid of. Our finished is going to be more, as you can see from the parts, it's going to be more like a casting. Or casting, yeah.
Yep, but what we can do is, in printing a whole giant tool to do like a door panel, that's not feasible as well. But again, it's identifying these specific areas on a larger tool where you have a problem point, you have a hot spot, something like that, and then going in and making, say, a 6x6 insert, that could be a door handle or something like that, and then we would insert that into a tool that was traditionally made.
So I wanted to ask you, you mentioned size just now, and historically, I think when we think about 3D printing, we tend to think of smaller objects, maybe because of the desktop printers that we've seen hitting the market the last 5+ years. What's the size limitations now that you have? Is it just the size of the machine? Is it time? Is it cost? Is it quality control when the object is larger, or?
Yeah, so it's somewhat all of the above. So on the metal side, the largest is 400 millimeters cubed, and then on the plastic side, our largest direction is about 700 millimeters. So we can get pretty big size part in that. But there's a lot of different limitations. So one of them is heating and cooling. There's a lot of thermal temperatures that go on in 3D printing. And if you make a part too large, one part's going to be of your finished part that you're making is going to cool down at a different rate while you're still overhill building, and you're going to get the potential for a lot of warpage and distortion in your part. Versus when it's very small, you'll have kind of uniform cooling throughout the part. There's the speed factor. I mentioned we're doing multiple lasers, but if you were going to make a machine that could do the carpet that we're sitting on, you might have to have 200 lasers or something to make a part like that, and that is the technology. We take powder, put it in, and use a laser to fuse the material together. the complexity to get 200 lasers all working together to make a part is a bit overkill, and then that would drive the cost of the product up right now.
Now, is that the case with all of the 3D processes? I mean, you guys do the powder and use a laser. I mean, there are some who use a liquid polymer, and they, build differently.
Yeah, so like the liquids are in a similar size range to the plastic machines, but there's other technologies where you might do like an FDM style machine, and that is you would start off with like a filament made of plastic or metal and then move a nozzle around to make the part. And that is a more simplified machine that could make it, and that would have the opportunity to go big, but there's trade-offs with everything, and that's going to be a slower process, and generally speaking, like I mentioned, an FDM part isn't going to be close to injection molding, so it might be great for a lot of applications. There's some companies that specialize in giant titanium machines the size of this room to do like structural components for aerospace.
So you were mentioning the FDM. So that's basically like taking fishing line, thick
Weed whacker
gauge-
trim.
Yeah, weed whacker stuff and melting it with a laser. So people may be familiar, what was it, Local Motors?
Yep.
Was that what they used, FDM? So,
We've got some stuff going with them with high temp material.
but I mean, they printed a car and said, so many of our viewers want to know, I mean, Bob Barrett said, how long before you're doing this at scale? How long before you're doing this in large size? I mean, when we think of making car stuff, we're not thinking of knobs, despite the fact that there are a zillion knobs in a car. We're thinking of like, we want a front fascia that's printed.
Yeah. So to go outside of auto for a second, just to maybe put some quantities in context, we've got aerospace parts that are in jet aircraft engine for fuel systems, and those probably around 100,000 units a year currently. And then even right here in the Midwest in Indiana, we've got a customer making medical implants, and they're making about 50,000 parts a year. So that's kind of where we're topping out right now in quantities. So if we look at automotive, the person who asked about tooling is correct. That is the shortest term goal. The big three are in production using conformally cooled tooling for injection molding and die casting. But as we look to the future, picking off the low running vehicles. So if GM wanted to come out with a special edition Corvette, that might be an opportunity to get that seat bracket that they've already designed into production, or maybe come out with a crazy turbocharger that could only be built, with this organic structure that might give them an extra 30 horsepower. And lower running vehicle, that would be a really good opportunity. The other one is the e-vehicles, and we're really high on that. As I mentioned, that there's a 100-year history on how to make existing parts, and if we jump over to electric vehicles, there isn't that same 100-year expertise in making certain parts. So something like a heat exchanger is a fantastic application for us, where the more surface area you have, the better it dissipates heat. With internal channels and organic shapes, we can make stuff that'll dissipate heat, and those are lower running vehicles as well. So the unit cost is down, and there's a need for complexity, and that's a great fit for us. And I think long term, additive manufacturing is almost like perfectly mirrors the electric car. We all probably can sit in this room and understand electric car makes a lot of sense. Anybody own one here? I don't.
Not yet.
Not at the moment.
We all think it's a great idea, but we can't justify the costs. They don't go far enough. The charging station doesn't make sense. There's not one near my house or at the mall or whatever. 3D printing is kind of like that. The early adopters are in it, and people are making, like I said, 100,000 parts, and everybody's circling around waiting for it to change. And I almost think the two things are going to go hand in hand. E-vehicles is going to be a great application for 3D printing, and then as we sell more electric vehicles, it's going to drive the cost down, give us more use case studies, and I think that'll help further adopt 3D printing in the automotive industry.
But for now, I mean, there's customization. You have a great example here of a real part that's being made by the Mini that I think is worth taking a look at. I don't think you saw this, Joe.
No.
Yes, we can pass these around. So this is a very new process. So you actually can go online to a website in an e-commerce store that Mini Cooper has done, and this is Mini Cooper Direct. And you go online, and they've identified a handful of components, both interior and exterior on the car. And you can go online and basically customize these badges for you.
Okay.
So in my case, I want it to say John's Mini. I can make it say John's Mini, and I could put a British flag in the background, and I could make it blue or red or green. And then they will 3D print this part at a central hub that they have in Germany. And then they will ship this directly to the consumer, and they're very easy to install.
So a question I had about this, and you mentioned some of the implications of moving to this kind of a process, but I'd like to see if we can talk about some more. So if you go to 3D printing for, an array of parts, do you also at some point get to shrink the size of the factory as well? I mean, because it seems like I've talked to people about this, and apparently there are implications if this scales up to, okay, how big a building do we need? How many buildings do we need? And how many people do we need in those buildings? Because you've got these 3D
Who are the
printers.
people making the parts?
And who are the people making the parts? So I don't know if that's something that's coming into focus and what some of the answers seem to be.
Yeah, that's a really complex topic that we could probably do like a whole other show on, but to just try and touch on that a little bit. So distributed manufacturing is a really interesting conversation where, especially in automotive, you have things to make a crankshaft. That is a tooled up specialty machine or a specialty grinder to make that crankshaft, and it only does one part all day long, and it's special, and then we change the model over. Now we have to retool these machines. A 3D printer doesn't care because there aren't, you don't have cutting tools like you're used to. You don't have, the molds, you don't have the die cast, all these different components. So with this technology, if I had space and I was making a 400 millimeter part, and I had a small tooling insert like this, and I had some more space over here, I could make a medical implant next to this. And it doesn't require any special tooling. It doesn't require any changeover. It's just got to be the same material. But I could make 2 titanium parts or 2 aluminum parts next to each other. And that's where the flexibility comes in. So in the future, you could have large contract manufacturers, and one day they're doing all Ford parts, and then the next day they're doing all Boeing parts, and there's no changeover. It's just uploading different files into the machines. The machines will be smaller. And then the other great thing is I sold CNC technology for about 10 years before I came and worked for EOS.
That's machine tools for those who are not familiar.
Milling machines, EDM, tooling, automation. And we always talked about lights out manufacturing. And the reality is there's a lot of things you can do with that technology to run around the clock, but in my opinion, you're never really to the point where you set a machine in a corner and you forget about it and it just runs and runs and runs. Our 3D printing machines.
Unless you have a screw machine. And it's just...
Yeah, I mean, there's some, but it's not as polished. First, I mentioned we have a 24-hour cycle time maybe, or a giant 400 millimeter insert might be a 100-hour build time. But the reality is our machines don't have moving components in the sense that traditional machine tools do. So the reliability is through the roof. And High Tech Mold, which is a local customer here in the greater Detroit area, their VP of sales, I was talking to him and asking him about, what are some of the stuff you tell customers to sell them on your 3D printing capability? And he said, the craziest thing is I walk by the room where our additive machines are. They have 2 of our M290 machines. I don't know if they're running or they're not. They're dead quiet. The lights are literally off in that room, and they just run around the clock. So even if it is a 24-hour build time, one operator can load the machine, hit cycle start, and walk away. And once the automation gets online, robots or electric carts are going to be very easily get the parts in and out of the systems.
Tell us about this part here before we're going to be which I think this is a real part for a car.
DS.
Explain. This is a fascinating part.
Yeah. So I mentioned we talked about mini and customization, and there's a lot of functional things that additive can do, like the seat bracket, and then there's the customization angle and the personalization angle with this. And this is for DS, which is the PSA's group premium brand. And their goal was to kind of give the car something unique and something distinct and to differentiate it from some of its competitors. So they 3D printed this insert on the top, and this is actually out of titanium. And the matching key fob has the exact same geometric pattern on it as well.
It's hard to appreciate if you hold it in your hands. There's actual depth there, like you could have dust or whatever go inside of it, but it's really an amazing finish. And it actually gets into the question that I had is, we've been talking a lot about commercialization, scale, and when are we going to see these, pumping out of factories in the thousands. But I feel like that, as an enthusiast, that mini personalization is pretty interesting. And I'm wondering if you think that we're going to get to the point where if I'm a car customizer or just one guy on the street that really likes, I'd like a certain wheel pattern. Will I be able to make up my own wheel pattern and send it off to somebody and have them do a one-off wheel, or will I be able to 3D print my own mirror brackets or whatever?
That exists today. So there's contract manufacturers, as I mentioned. It's not like today you have mold specialists, you have medical contract manufacturers, you have first-tier auto supplier, you have the aerospace guys. A general 3D printing service provider has machines, and basically the limitation is, does I fit in the machine, and then am I running the material you want?
And am I willing to pay the cost for it? So what I'm talking about is getting it down to a level where an individual enthusiast, maybe it's 30% more per, to get the front valance the way that I want it, or the wheel pattern that I want is 50% more, but it's just mine.
Yeah, I mean, like you were mentioning the cost. I mean, if you had a wheel that you wanted and it fit in 400 millimeters, and let's say you wanted titanium or something, I could give you a dozen people the call that if you had this designed out and drawn in CAD already, I could make this for you. It's tough to figure out kind of the cost point, but some of the customization for wheels and things like that, especially bigger machines coming out in future years, I mean, I think that could be a pretty good application where, like with the Mini, you could go online and design your wheel and have it come out.
So are wheels, I'm not sure they are, but are wheels sort of within the capability of the technology now, or no, right? Or are they?
The size would be like you couldn't do a 22-inch wheel for a
right.
Yukon or something like that, but a smaller wheel, you could absolutely do that. And again, technology, I mentioned the complexities of getting the technology bigger a little bit earlier, but we are trying to go bigger, and at some point in the next few years, I'm sure there will be larger machines on the market.
It does seem like customization is an opportunity for your business,
Yeah.
right? I mean, instead of, okay, fine, you can't support 1 million, trucks a year, but if somebody wanted to do, like the Raptor or something like that, some of these limited edition vehicles that are constantly coming out, that seems like it's inside the envelope for you.
Yeah, I mean, those are the applications. And again, unfortunately, nobody sends us a file to even time study or build a benchmark part without NDAs. And this is all stuff that might be 5 years out. But that's exactly the type of application. It's the specialty edition trucks. It's the specialty edition sports cars where you're kind of, the lower running vehicles. And again, as the next 5 years, the next 10 years, cost comes down, speed's going to improve, and the entire industry is moving toward that, as well as things like Industry 4.0, where we can play with big data. We have partnerships with Siemens and SAP, and a lot of the stuff that you read about or hear about is actually going to come to market.
So is there
I can do a rapid fire here with these, and then we're going to have to cut them loose. So sorry about that, Joe. So quick answers, right? Cost and time associated with engineering changes, additive versus conventional.
It's the time it takes you in CAD, but like if you had to do a mold revision, it's just changing the CAD and hitting build.
Okay, that was Bob Barrett. Dave Tuttle, he asked about the molds. We've already had that. Mike in San Francisco, 3D General Motors, we saw that. Okay, here's a question from him. How long do you think it'll take before we have an IBM Watson supercomputer that's running a factory controlling every component that 3D printers will make and the robots will assemble?
So AI was used on the Autodesk side with this GM part. So again, the technology exists today, and I have a part built, but unfortunately I don't have the crystal ball to know if we're going to have the big three with these factories. It's probably at least 10 years out.
Okay. Albert Mancolosso wants to know, what is the feasibility of steel, aluminum, magnesium, or titanium metal powder being used to print parts for classic or non-existent vehicles, whether they're blocks or just specific parts?
Every single one of those materials you just named, other than magnesium, is a standard material offering from us. So as long as, and with 3D scanning, if I needed some old bracket, I could put it in a 3D scanner. That would generate the CAD file. I take the 3D CAD file, put it in our slicer, and then you can build it. So there's a part that we have as well that I think was on the title card for today, which was they redid a Volkswagen frame. And that was done with that technology.
Right, and we're looking at it right now. So this is what a frame of the future might look like.
Exactly. So they took an old Volkswagen, a very simple car, scanned the frame, designed the CAD around it. EOS, Airbus, Altair worked together, redesigned that frame to take advantage of 3D printing, and that's what it looks like. But hypothetically, if they wanted to just build the frame that previously existed and not go with the organic shapes and restore a car to its original shape, that's something we could do.
So that's multiple pieces, right? I mean,
Yeah, you can actually see the
I can
welds.
see the weld, yeah.
And again, that's And it's real metal. It'd be just like taking a forging. So when it is too big for the machine, that's a great application. They weld the different pieces together to get your finished part.
Okay.
And there are companies that are actually, like I think Jaguar is one of them that are doing some of their classics business. They're getting into 3D printing for, the multi-million-dollar cars where they need that one part where they either have to make the mold using 3D printing or they make an actual part. It's already happening.
Daimler's doing spare parts as well with their plastic machines on low-run interior components on buses. So when something on a bus that maybe they only make 5 a year, instead of worrying about the maintenance, inventory, or tooling costs, they're just 3D printing those on demand as they break.
Seems like Class 8 trucks, similar, right? And the volumes are not as out of balance.
Exactly.
Yeah.
All right, final question.
Sorry, Gary.
NC wants to know, how does the strength and other characteristics compare to other types of production?
So all of the materials that we run, whether it's metal or plastic, come with the material data sheet. And on the plastics, the goal we always strive for is injection molding. And if you looked at 10 possible characteristics, we will meet or exceed probably 8 out of the 10. And on the metal side, it's going to be 10 for 10, generally speaking. You're going to get 99.9 or 100% dense material that'll match wrought or forged.
Okay. That, John Walker, EOS, thanks for coming in.
Thanks for having us. We appreciate it.
It's great. I think these guys are just going crazy with questions, and so
we love
I'm
it.
glad we brought you on.
Yeah, really excited to do more and more with auto. Like, we're right at the apex of the next 5 years, 10 years. There's so many 3D printing automotive examples. It's fun to come on now and see where it all ends up in a few years.
Great. Okay, thank you very much. And we're going to take a quick break and hear from our good sponsors at Lear and Bridgestone.
Lear Connexus offers a parental controls application with geofencing that sends notifications regarding driving behavior and location, including curfew alerts, acceleration alerts, and speed alerts. All delivered to a smartphone application that includes vehicle location, driver notifications, and a report card of driving history, including notifications when predefined geographic boundaries are crossed. For more information, visit Lear.com.
You look at people who maintain some classic cars, there seems to be a nice opportunity to there. And if you buy into a future where most people or a lot of transportation is autonomous, but you still have sort of garage mentality, or the analogy to people owning horses, right? That could be a really lucrative business in a decade when you can't get parts for certain things.
It's very cool stuff.
Yeah.
Yeah, and it does seem to be, reaching a point where the sort of science project phase of the development is over, and practical applications are starting to come into focus.
Yeah,
So
there's already a little cottage industry around some of that stuff. I've had 3D printed parts on a couple of my cars already, just because they're out of production parts, like a jack stand cover for an old Saab that I had that goes on there, or I have a car that
POW.
Yeah, right. I have the POW has 3D printed parts. They're just little simple brackets because. It's a Japanese market car.
Yeah, no, I remember
and
the car, yeah.
the license plate holes are in a different spot than they are with the U.S., and so you have to get basically like little adapters. And nobody made those, so somebody started 3D printing them and selling them on eBay for $15. They're pieces of plastic this big, and you know what? I bought one because it's way better than any other re-drilling of anything.
Well, and I think, John, you might have alluded to this, but the idea that if you, first of all, that you can you can have 3D parts makers who are 3D parts makers. They're not, some supplier or Delphi or the OEM. They make 3D parts, and you can be anywhere in the world. And your Mercedes-Benz truck or your Ford truck breaks down. You need a part. Somebody says, print the part. I mean, so it doesn't take too much imagination to see where you could kind of reshuffle a lot of the aftermarket parts and repair parts, warranty
inventory
parts
distribution
business.
all changes.
And that too.
Well, and back to new cars too. And an interesting component was that they could build molds out of that. And so you've got you can probably solve some engineering problems that a little bit easier and faster, even if it's not going to the point where you're building the whole car.
Yeah, and there are companies that are making, they have other types of machines that John's company doesn't have, that they're basically making, these quick molds. Because, if you're going to make a mold, it generally takes on the order of 6 to 8 weeks, and then you've got to try it, and it's like, oops, this doesn't work, and then you got another 6 to 8 weeks, and try it again, and these guys can just print it much quicker.
Well, and the interesting part, as they talked about having sort of the inside of the mold, literally doing things that you couldn't do with a different type of a mold development process, I thought was interesting as well.
All right, so fun part aside, now it's time for Dr. Data.
Oh, boy.
Okay, so this one actually is a fun one. So Carmen or Katie, could you please bring the first slide up? So this is going to be a little different. Okay, so 1 out of 6 drivers on the 395 express lanes. Now this is in Washington, D.C. Okay, the 395 in Washington, it's an interstate, right? Okay, so this is a choice. Now you guys have to remember this is a multiple choice question. Okay, so it's 1 out of 6 drivers on 395 do. Next. They sing while driving. Next. Hold their cell phone while driving. Next. Read while driving. Next. Eat while driving. Or watch Fox News while driving.
I'm going with E. I think all of the above, first of all. But second of all, it's outrageous, so I'll go with E.
I mean, the phone percentage seems low.
Yeah, I was.
1 out of 6,
that's-
I'm guessing read.
Yeah.
Yeah.
So read.
That's my guess.
But are they reading on their phone?
No, the
we're
picture
just-
was a book, so.
Yeah.
Okay,
We're going with that.
You say
I'm going to say phone, but I'm going to say it feels too low.
Wait.
I'm going to say watch Fox News, but man, and I'm with Chris on the phone. I think it's too low.
yeah. And the answer is phone.
Really? Mm-hmm. They're lying.
Yeah.
So you think that they're underreporting?
Is this
Look, I've been on-
self-reported? Is it people admitting the behavior, or was
Yeah.
it like a scientific study?
No, this was a survey that the.
So I've been a lot on that road. So first of all, expressway is a misnomer. Second of all, yeah,
So basically, it's clogged.
it's clogged all the time.
Clogged
Anyway,
doesn't
I mean,
have
look,
quite
the
the
Fox
same
News.
Clogged is.
Fox News
I
thing
like
is
the
probably a
Fox
joke, but
News.
it may not be as far off as you think.
Well,
and yeah,
Your
distraction.
statistics said 20% admitted that they almost had an accident from looking at. That's an entirely different thing than how many are holding.
No. I just thought no. It was that was a separate data point, and I thought it was pretty funny that here we have these people who are basically saying that they nearly had a tragic accident, yet they still seem to be holding their phones.
So I don't know where you're going with this, but I think it does point to something.
That was the end.
Well, that was the end. Well, then I'll take it one step further. I mean, I think that does point to something that the industry, the auto industry, let alone safety and other groups, really needs to think about, which is that in a lot of urban centers in Washington is one of the worst. Driving in the environment that the car provides is like the least important thing that's going on in the car. I mean, people are like, okay, I'm going 20 miles an hour. I'm in this ridiculous traffic jam. I'm going to whip out the phone and I'm going to start sending emails and I'm going to do this and I'm going to do that. And that's a problem.
So while we're on the subject of Washington, so the Detroit 3 went to Washington last Friday and met with President Trump. We got a question here from Eric Winkler. So one of the topics was supposed to be CAFE, right? That the fuel economy standard, and that was basically the main reason, and I think maybe a little bit of NAFTA, but it seemed that none of that was really discussed, and so
It was.
Hard to say.
But there
Hard
was
to
no
say.
resolution.
okay. So
And the public remarks versus the actual meeting, I think, are two
all
different
right,
things.
so we have a question from Eric Winkler who wants to know, who's saying, okay, there's the issue with California and the California CARB states, the ones that follow the California rules, and saying, if he lives in Massachusetts and it must be equipped with factory installed California certified, is that going to be different than a car he could buy in New Hampshire?
That's the question. I'm not sure about New Hampshire, by the way. I can't
think
remember
it's
if they're
maybe
in
not a carb-
the
I think he's
California pack,
implying
but
it's not
Ohio.
carb.
Okay.
Okay.
And I'm quite sure Ohio would be different. So that is something that the automakers have discussed with the administration, and I think they actually raised it with the president, which is what they want is one set of rules. And they're very concerned. I think all the auto lobby and the car companies have been pretty public about this. They're very concerned that where we seem to be headed is to at least 2, maybe more sets of rules. And if California essentially secedes from Cafe Nation and takes 17 other states along with it, then that is a worst case scenario for the industry, because then they have to figure out, okay, what do we do? I mean, do we overspec everything to the California standard, and in however many states, I can't do math, but 33 states or whatever, we're kind of overspec.
44% of the auto market is represented by.
More interesting perspective.
Yeah, but no, that's right. I mean, the population, anyway, but the point is you're overspec for some set of the market. or what do you do? And it's just a whole lot simpler to have
One standard.
rule.
So
Yeah.
that, I mean, so
And
so
that
where
is-
we are right now, isn't that what the thing is? I mean,
Well, it's
isn't the plan that we're going to have one standard, and,
It was
and
the
that's
plan.
why
That's the plan.
everybody
The plan was
signed
one
on to that,
standard.
and now the administration is suggesting that we might want to ratchet that back, and then California and these other states have filed suit
17
against,
states have filed suit.
against the government.
And oh, by
saying-
the way, New Hampshire isn't part of it. So anyway.
It all feels very messy right now, and there's several layers. Part of it is that the administration has said, okay, we want this rule. We don't want the entire country's emissions regulations to be driven by one state. The state says, well, that's nice.
well, one
we want to
state-
control our state.
Yeah.
The others only have the option of signing out at the moment. Only have the option of signing on to what California has done. They don't have the option of creating their own.
Right.
That's
So-
unlikely to change, I think.
That's unlikely to change.
Right.
I agree.
So there wouldn't be a Michigan standard and an Ohio
No.
standard.
No,
and
no,
an
no.
Illinois-
I think it'll still be California because they're grandfathered in,
Right.
having their previous own. Isn't that fair to say that?
At the moment, but that's one of the
That's
things
right.
that
One
the
of the issues.
administration.
But I don't think they would add additional.
No, they're not going to add additional.
Okay, so at the meeting that we heard publicly, because Steph, as you pointed out, there is the public statements and then the statements that we didn't hear. The president said that he wants the Detroit automakers to bring more manufacturing.
Millions was the number I think he
He
threw
wants
around.
millions.
He
of-
likes big numbers.
Right. So, okay, so what's that all about?
So that's a good question. Okay, that's a really good question. I mean, if you take what the president said on face value, if you take what he said on face value, what he was essentially saying was that we want to replace all imported vehicles with vehicles that are produced in the United States. And Stephanie's shaking her head, and with good reason,
unrealistic.
right? Because the chances that automakers are going to that German or Korean or Japanese automakers are going to hollow out their national industries and transplant them to here are zero. They've already moved a lot of production here, and they have problems with that, I'm sure, in their home countries. That's kind of the first thing. And the second thing is, if you look at sort of the competing, the mouths that have to be fed with limited capex in this industry, where are you going to put a new factory? Well, it's not the United States, probably. I mean, yes, Toyota and Mazda built a factory here, but if you really have to choose, you're going to put it in China, which, by the way, the automakers are doing. I mean, I went to the Beijing Auto Show, right, and listened to Audi and all these other different companies say, we're going to build more and more and more in China. So, if they've got $1 billion to spend on a factory, they're not necessarily going to put it in NAFTA. They're going to look at China.
Well, there's a few reasons for that. I mean, part of it has to do with China still has some space for capacity. It's getting close, where its market still has more growth than for sales than it does for manufacturing. So there's still some space there. In North America, this is a mature market. There's no growth, not very much to be speaking of here. So why would you build new manufacturing here? You have to sort of take it from someplace else. But most of the manufacturing being talked about in China at the moment is to feed the Chinese market. Some of that will ultimately come here, but at this point, it's more lower volume that comes here. Buick Envision would be one, right?
Right.
You see something that would, as an example there, that sells 200,000 or 300,000 units in China, 40,000 units here. You may see something like that, but right now those projects that you were talking about aren't necessarily products that would be primarily built for the United States.
Oh, no, that's what I meant. But I'm
Right.
just saying from a corporate, like the CapEx,
Yeah.
fan, it's like, where are we going to put money?
Right.
You're gonna put it in the-
And I think, to the earlier point, I mean, first of all, Toyota's biggest plant in the world is in Georgetown, Kentucky. I mean, it's not in Toyota City, Japan. BMW makes all of its SUVs for the world in Spartanburg.
Plus some China.
And their center of excellence, at least,
Right.
would be
Is
here.
it-
I mean, and
This is significant.
Honda's got, how many assembly plants here, so on and so forth. So
A lot.
Volvo's just
Volvo's just
opening.
about to get going. Yeah.
Right.
Here,
And so it just sort of seems unrealistic to think that we're going to get millions of more jobs, because it seems that, many of the cars, I mean, you mentioned the Envision
Volvo's the S90 comes out of China right now.
and I mean, but even domestic automakers make cars. The EcoSport is made in
India.
India, right? I mean,
Yeah.
it's brought here. So it's like he's telling these car makers, who have made business decisions that they want to be elsewhere.
Well, right, and the problem is that the trade policy discussion that's being had in Washington now is a trade policy discussion that's a lot of echoes of the 1980s, but right, and quotas and all the rest of this stuff, and the problem is that it was kind of a dubious conversation in the 1980s. It's a really dubious conversation now. I mean, the barn door has been open on globalization and the distribution of supply chains and all the rest of this stuff that Steffi's company, tracks very closely. The barn door has been wide open for decades, and the horse is like, who knows where?
You're not getting him back in the barn.
The horse is way out of the barn, and it just seems like this idea that, we can just reverse all of that and undo it all, and so we're going to go back to 1956. I'm not sure the industry is really going to do that.
It feels like a rebuilding the coal industry type of conversation, right? It doesn't. The math doesn't work on it anymore, and it doesn't work necessarily on for the companies even here in the U.S., right? I mean, GM builds more vehicles, sells more vehicles abroad than it does here stateside now, right? I mean, it's pretty close.
They sell more in China, right?
I believe they do sell more.
Yeah.
Yeah, they do sell more in China.
Yeah, and
but
Volkswagen sells. I mean, again, auto shows may be passé, and I don't know if that's a topic or not, but auto shows may be passé, but they do have some utility. And going to the Beijing Auto Show and just kind of listening to the way in which industry leaders said, essentially to the Chinese government, they're basically addressing the Chinese customer and the Chinese government, and said, we are going to keep investing in China. We are doubling down in China. We're going to put more of our technology and engineering and IP in China. And it was basically like, never mind what's going on in Washington. Mm-hmm. We're focused here.
So they are focused there, and auto shows kind of gets related to that. There's almost a regionalization happening. You talk about, we opened the globalization years ago, but when you look at vehicles being developed either for China or for the U.S. or for Europe, and none of the three of them being quite the same, more similarities between U.S. and China in terms of consumer demand than Europe, but we are seeing more and more things coming out that are regionalized, and it feels like that's a bit where we're headed, because China's big enough to support its own space, right? The U.S. and North America is big enough. You can build and sell pretty close. I mean, as much as we want to talk about bringing more vehicles, the government wants to talk about bringing more production here, we're not that far off. There aren't millions more, to your point, to bring in. The ones that are imported here are imported because it makes more sense to build them somewhere else. The EcoSport, imported from India, it sells in much greater numbers in other parts of the world than it does in the United States. It doesn't make sense to bring it here, where it's higher cost.
And look, so let's take the president seriously, if not literally. If you take him seriously, I think the main targets of his policy kind of directives or pronouncements are really the German automakers. To a large extent. I mean, yes, the Hyundai and the Japanese automakers import a fair number of vehicles, but I think the real risk, if we went to a real closed-door policy, would be to the German automakers, because a lot of their stuff, outside of the SUVs, is still imported, and it does seem like a lot. It's interesting. I don't quite understand it, but I mean, a lot of of the president's concerns seem to be directed at the German automakers.
So actually, we have a question from Mike in San Francisco, which directed to you.
Okay.
And it says, you said that German auto companies are willing to build a factory in China. Why not the United States, or risk a 25 to 30% tariff, which is what some EU countries charge on U.S. exports? So
I would say, I'm sort of paraphrasing crudely what the German auto executives said themselves in Beijing. Their view is that China, is the growth market, and that if they have to invest anywhere in additional capacity, the place they're going to do it is China. Look, I could wake up tomorrow and BMW or Mercedes or Volkswagen could announce yet another plant. Although really, if you look at it, BMW and Mercedes have invested a ton of money. Well, first of all, they're probably not. But second of all, they've invested a ton of money and have giant factories in the United States. Mm-hmm. I mean, the BMW Spartanburg is the biggest exporting auto exporter, single point auto exporter in the United States. Mm-hmm. So I think from a German perspective, their view is, wow, we've invested significantly in the United States, and our future in terms of sales is in China. So we're now turning our attention to that market.
Right.
What's wrong with that? That's a,
Well, and
So,
China does-
Chris,
China-
you're the car guy here, and well, I mean, come on, you're the car guy.
I mean,
You're the car-
everybody
but-
loves
but-
cars here.
But you okay? So the thing I sort of wonder about is that what vehicles that are built in the United States are likely to be sold in Europe? I mean, it's just like, I mean, it's the thing I wonder about. I mean, people want to buy BMW 3 Series, right? I mean, it's like, oh, that's a great car. I want to buy a 3 Series. But I mean, is there somebody clamoring in Munich for something that's built here?
Regrettably, I don't think there is.
Not much.
No.
And you guys track this stuff, right? I
Yeah,
mean,
no. There is a difference. Europe does like things a little bit smaller.
right.
Smaller, faster, more efficient.
Right. So it's just a different game. So speaking of efficiency, segue in, and Joe, you mentioned this earlier on that we're seeing rising oil prices, and so gasoline is. I noticed on the way to the studio today, it's now $3 a gallon, and as I am wont to do, I checked the number the Energy Information Administration website today. The average retail price for gasoline on May 15th, 2017, which was a year ago, was $2.36 a gallon. In May 14th, average $2.87 a gallon. So basically 50 cent increase over a year's time. And it seems as though we haven't seen the end of this. What do you guys think this is going to do to the mania toward building more crossovers, especially 3-row crossovers, or more, what is that shape?
I don't think it's going to do anything.
You don't think it's going to do anything?
Stephanie, I'd like to hear what because I'm sure this is a question that IHS's clients are asking.
Well, yeah, and we look at it
aggressively.
quite a bit. I think that right now the economic indicators are still strong. And I think it's not just fuel prices going up. I mean, as U.S. consumers, we're used to them coming up and down and being kind of all over the place. The real sort of danger spot is when they're coming up and there's either a perception or a reality of wages coming down and economics coming down. If you are concerned about making, your mortgage next month, then all of a sudden rising fuel costs has a much bigger impact and is a much bigger worry than it is otherwise. Right now, wages are only going up slowly, but they are going up. We're at 3.9% unemployment right now. All of those things are really good, and they make you feel comfortable. You don't like paying 50 cents more at the pump this May than you did last May, but you kind of didn't notice. You kind of forgot exactly what you paid last May, and it's not such a big thing by itself.
So you don't think that a number like $3 is going to make people say, wait a minute?
It might make some fleet people a little concerned about deferring purchases of 100 F-150s. They might say, well, maybe I'm not going to do that right now.
Yeah, if you
but it's
don't
the
need
economic indicators too, right? And I think the reality is people are looking at, say, Ford's move to get away from sedans. Being a very high-profile example of that, and Accord having trouble, or Honda having trouble selling Accords. And saying, well, in a few years' time, everybody's going to want these smaller, fuel-efficient vehicles again. I don't really think that's the case, because I think the gulf between the old SUVs, the old body-on-frame stuff, and even the early crossovers, and today's modern crossover versus its sedan equivalent, there's very little difference there in efficiency. And you're getting increasing amounts of electrification that will eventually wallpaper over those differences in gas prices. Right. I mean, it's a long game to get there, but
I agree with that. Certainly in the medium term, I agree with that. And the more electrification happens, and we can argue at a different show maybe about how fast that'll happen, but it's going to happen. Mm-hmm. So the more you get to electrification, the less concern that anybody's going to have about oil prices. I mean, I do think that $4 a gallon would freak people out and would cause certainly a disturbance in the force. But I'm not sure that $3 a gallon is really going to make that big a difference.
What about $3.50?
Well, it depends too on how much it holds. It depends on kind of what else is going on, and it might cause people to delay stuff a little bit. But when people shop, they tend to look at what a vehicle is doing for their lifestyle first. before you kind of get into fuel efficiency issues. And if you've got a RAV4 that can do more or less what your Camry can do, and your penalty isn't that high, even if your difference between is 3 miles per gallon, at $2,
You're still
it
gonna
doesn't.
you're still gonna buy
it
the
doesn't
RAV4?
Make, yeah, it doesn't
Yeah,
make
over the
a
life
huge
of-
amount of difference
yeah.
over the life of the vehicle,
Right.
over your weekly expenses.
And that's why, hybrid sales and even plug-in sales are still tiny.
Right.
And people, if you survey, the American car buying public and say, will your next car be a hybrid or a pure electric? And, a large percentage of them are going to say, absolutely, that's what I'm going to consider. Maybe because they think that's what the surveyor wants to hear, because they want to feel better about themselves. But then the reality is they go to the dealership and they say, well, this payment is this, and this payment for the hybrid is 20% more, whatever. And they do the math, and they're like, I'm just not.
It's not that.
Yeah,
not that important.
I think it's going to take a sustained kind of much higher than currently gas prices. And the other thing is that, and again, I'm not really an expert on the oil markets. Okay, I have colleagues who are, but they say that in reality, the supplies of oil are still massive. I mean, there's oil all over the place, and fracking and all the rest, and the technology to extract oil has created a situation where fundamentally there's plenty of oil. So there's various geopolitical reasons why oil prices bounce up and down. I mean, our policy toward Iran has an impact on it. Saudi Arabia's policies have a certain amount of impact on it. But
Venezuela's economy has an impact on it.
well, right, but so we're kind of at a cycle right now where there's tensions with Iran are up, Venezuela's economy's a mess, so on and so forth. So we have a rise, but the fundamentals suggest that if oil's pretty available. So
Right.
All right,
There's
last
always
topic,
supply and demand.
last topic. Okay, we can't do a show without talking about Tesla. So earlier this week, Elon came out and sent a memo to all of his people saying, quote, to ensure that Tesla is well prepared for the future, we have been undertaking a thorough reorganization of our company. As part of the reorg, we are flattening the management structure to improve communication, combining functions where sensible, and trimming activities that are not vital to the success of our mission. Now,
he had a colorful way of explaining what he was going to do, which he used in a conference call. He said, we're going to scrape the barnacles off the organization.
And that was a reference to suppliers as much as employees. That was a supplier.
There was kind of an
conversation.
all-encompassing.
Yeah.
I think barnacles come in many shapes and sizes.
I thought this was supposed to be a super efficient company, people, with no fat on the bone.
No.
okay, so
I mean, that's what it's been pitched at the whole time, right?
So he lost an executive, Matthew
a lot.
Schwal, who was primary contact with safety regulators, who went to work for Waymo, which is the Google self-driving car company, and then Doug Field, the senior VP of engineering.
Taking a few weeks off.
He's
In the middle of
taking some time off to
launch.
recharge. And this guy, I mean, I know Doug, and he's an amazing guy. He worked for Segway, he worked for Apple. I mean, he's the engineer's engineer. And so, okay, here's my question. Is this of interest only because it's Tesla, and were this to be, I don't know, Hyundai or some other company, we wouldn't even pay any attention to it?
I think the story gets framed differently. I mean, every time you get an executive change at a traditional automaker, it gets noted. But right now, especially to use a loose term, mainstream media or whatever, the titles and the headlines that tend to go with it, the cast of the stories tends to make it sound like it's a bigger deal. But at the same time, some of the people that you've mentioned Doug was at 3 companies before he was at Tesla. We also are looking at a Silicon Valley area where people do tend to change jobs more and tend to not always be with the same company. I think that's probably part of this factor
So
as
it's
well.
just natural that that's the environment that they live in?
It's also a really intense space. It's got to be an intense company to be at right now.
Yeah, Steffi's right. I mean, my sense of Tesla, and talk to people who've been at Tesla, is that it's very intense. They're trying to do something that, by and large, hasn't been done before. They're obviously, I mean, this is pretty obvious. I mean, Elon Musk has admitted it. I mean, they're having a lot of trouble producing that car. They're having a lot of trouble with the system that they built to produce the Model 3 and the batteries that go in it. I can only imagine how stressful that environment is for the people who are responsible for hitting the numbers that Elon has promised the investors that he will hit. And, again, he may be getting closer to those numbers than I know, but when we last had some visibility, he was roughly half the distance to the goal, and had given himself 6 or 7 weeks to get there. And so one, I mean, yes, Silicon Valley is a different kind of environment, and people don't stick around in companies for 30 years the way they used to do here. And by the way, they don't even do that here.
Right.
Second, I mean, if you told me that somebody who was involved with the Model 3 launch had gotten to a point personally where they needed time off or their health was going to break, I would say I believe that. I just do, because it's an incredibly ambitious thing he's trying to do.
And his reorganization, he said that he wants to pull things out that are not critical to the mission. Go look at their mission statement. Their mission statement is not to build cars.
Right. Okay, so I'm going to give you the final question, Chris.
Oh dear. It's a lot of pressure.
When
You'll need a break.
when do we stop talking about Tesla? When is it going to be a show where I won't feel compelled to bring up that company? When does it just become either just a car company or just something you don't talk about anymore?
I don't think there is a near-term horizon for this discussion to stop. Because whether they succeed and they continue to do these amazing things, I mean, the Model 3 is an amazing vehicle, right? I mean, the build quality may be lousy of a lot of things, but it is fundamentally, performance-wise, design-wise, it is an amazing vehicle. It is an incredible accomplishment. And we're going to continue to see a lot of those things, especially since they pull new designs out of the cupboard quite regularly when they're still years from production. So we're still going to be talking about it. And Musk is a larger-than-life personality. There's no way we're going to stop talking about them in the near term. If they cease to be an automaker, with their present financial situation, certainly a possibility. I mean, I think, in all honesty, they'll probably potentially get bought by somebody down the road, but it's going to be years.
All right, so I have a question. Each of you gets to answer this. Okay, $4 a gallon gasoline, Tesla being a production success. Which happens first? Joe.
I can't answer that. I guess I would say that it's probably more likely that Tesla will figure out its production problems before there's a spike to $4 a gallon. I'm going to guess that.
Stephanie.
I'm agreeing with Joe, yeah.
Boy, I'm a cynic. I'm going with gas.
All right.
I am.
It'd be boring if we all agreed.
Well, I'm just looking at the amount of issues that they had getting the Model S out initially, and the rate of improvement for that vehicle, which still has problems. And then they developed the Model X, and they put those ridiculous doors in it, which anybody could have told you that was a disastrous idea from a production standpoint. Continue to have problems with that. I would have thought that the Model 3, they would have gotten a lot closer to building a vehicle that was designed for production. And I just feel like they didn't do that. They didn't go through all those normal iterative processes. They didn't test the tooling ahead of time before they installed it in the factory and all that. And they're reaping what they sowed. I mean, they had a disorganized, hyper-accelerated process, and that's what they have again. And I can only imagine that that's exactly what's happening with the Semi and the Model Y, because I just think it's a different sort of mindset that goes from a tech company where you're really good at doing things quickly and then iterating on the fly, and you're beta testing while the product is out in public and all of that. You're making these minute adjustments all the way. But as we all know, cars are much, much more complicated than that. And I just don't see the learning curve there yet. And with the competition that's coming in from all these other established automakers that know how to build cars, know how to build them well, know how to build them at a profit, into the electric car space.
All right.
Well, and you got to define success too. I mean, do we get to sort of the target they want for Model 3, or is it somewhere down the road?
Yeah.
And whenever Elon Musk is answering a question about production, he's including that battery pack. And most automakers are not necessarily. You talk about assembling a vehicle, your engine's done someplace else, and they're generally kind of two conversations. F-150's problems had nothing to do with engines, right? It was a supplier, but still, Musk is also including that, and it's almost a little disturbing that he's had so many problems with the battery pack.
The battery packs
assembly.
Again, he said himself, the battery packs where a lot of the assembly problems have been,
Right.
is getting enough of them.
And that was the stuff that he was supposed to know better.
Yeah,
than
I mean,
others.
but I will say this. I mean, and companies got all kinds of operational problems, no doubt. But he also put a car on the market, the Model 3, and sight unseen, he had hundreds of thousands of orders, and I believe now is claiming to have somewhere in the neighborhood of 400 to 500,000 orders. That's a pretty big deal, and you can bet that the competition is very concerned about that. And I agree with you, Chris, that the real test of this will be over the next 2 to 3 years as the Germans and as other companies, probably GM, maybe Ford, start fielding fully electric, well-designed, appealing vehicles into that same space that Elon Musk is trying to inhabit. And you have a market of one right now, in Tesla. When you get a market of 20, it'll be interesting to see what happens.
Okay, final word. That's it. So, Joe White, Reuters, that was great. Thank you very much. Chris Paukert, Roadshow by CNET. See your stuff online.
Every once in a while.
Stuff online. And Stephanie Brinley from IHS.
Yeah.
It's
Thanks for having
great.
me here again.
And see, I needed all you guys because no John, and so you did it. Did
We
great.
hardly
Okay.
knew he wasn't here.
Shh. All right, join us next week. I promise we'll probably talk about Tesla. We're going to have someone from Continental Automotive who's a powertrain guy, and Continental's doing a lot of electrification.
Yeah.
So we'll probably talk. So thanks for joining us, and see y'all again.
Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion, and by Lear, a global leader in automotive seating and electrical systems.
Visit our website, Autoline.tv, where you can watch us live Thursday afternoons. Get your daily fix with Autoline Daily and in-depth analysis and interviews with Autoline This Week. There's all that and much more at Autoline.tv.
All right, so for those of you who are still on, I've just been advised it's in 2 weeks, so this will be on the 31st. It will not be next week. Is next week a holiday or something?
No.
Memorial Day? Yeah, I think
It'll be in 2
Well,
weeks.
but that's Monday, not
It's
Thursday.
Monday, not Thursday.
Oh,
But
whatever. So,
whatever.
We're taking at SAE, I believe.
okay, Continental 2 weeks from now. So if you're still there, and if not, watch an old show. Watch the Sandy Monroe show about the Model 3, which is completely sensational show.
It was a great show.
This is better though.
Yeah.
Yeah, I got you guys.
Pretty good.
This-
I'll go with pretty good.
Pretty good.
Sandy Monroe and the Model 3, that's a special one.
Yeah.
That was a really great show. In fact, I was at a Swedish car specialist a couple days ago, repair shop, and somebody came in and we were talking about the industry. It was just somebody that happened to be there, and they referenced that show because we started talking about Tesla, and he's like, "Oh, you wouldn't believe the incredible." Chassis design and the motor and the power electronics and all that stuff, but the rest of it's just crap.
Yeah. That's a good question. We'll see what happens.
To the car?
Yeah.
No, I agree. You don't get to stop asking questions about Tesla for a while.
A long time.
Yeah, I
They're,
agree.
I mean, they're fascinating, and honest to God, I mean, they're the biggest driver of innovation.